Right. Thank you, everyone, for joining our prompt lab, how to write the best prompts. My name is Soraya, and this is my pleasure to be hosting you for the next 1 hour ahead. Yeah, a little bit about me. I'm a founder of Aiku. We are a company specializing in applied AI. We bring automation to the industry to enable better and healthier community. We create, we prototype, we design and prototype and develop the customized AI software. And we also provide learning platforms for individuals and teams to build their own Gen AI, as well as to upskill themselves. And together with me today, we have Ziggy, who will be taking over the session and introduce himself later. So what is Prompt Lab? Many of you have been here before and watched the session or were there, but I would like to introduce what Prompt Lab is. It's a series of 5 online learning sessions covering the most central topic in the space of Gen AI right now, which is how to write the best prompts and how to get the best out of your Gen AI tools that are available. So what's so special about Prompt Lab is that it's hands-on. So we want to provide hands-on practical sessions. So the knowledge that you can use immediately. It's also flexible. It's online. And if you are not here with us, you can always watch it on YouTube. It's completely free. So it's inclusive. And although we have 1 hour each time, we try to be as interactive as possible. So if you have any questions, um, write it down on the chat box and we will get back to you at the end of the session to address your questions. So this is the third session of our prompt lab. We will talk about advanced techniques, so more reliable prompts with some advanced techniques together with Ziggy. And if you have missed our first and second sessions, I have pasted the links to the YouTube videos for you to access. And many of you probably already have that in your email, or you can also join our WhatsApp channel. Thank you, Ziggy. This is our WhatsApp community where you can get updates and also ask questions and get feedback from the community. All right, that's all from me. And Ziggy, can you please introduce yourself and take over from this point onwards?
Yeah, thank you for reminding me, because the last 2 sessions I forgot to introduce myself. I got head over heels into the content. Yeah, so co-founding this with Aiku, as you can see, proudly wearing the T-shirt here, and doing most of the technical work. And since I'm also working at Research Institute at the Fraunhofer Institute, where with a project we want to drive adoption of AI, this larger topic of enabling people to get the best out of prompts emerged from this larger context. Let's say that people should just apply way more AI into their day-to-day work and so on. And this is why we're basically here and why we're so glad to do this. And let's dive into what we have today. And it is about breaching the limits of, let's say, standard prompting. In the last sessions, where with the first session, we had, let's say, the basics covered, how to structure a prompt. Second session was about how to make sense of the quality and potentially improve the quality a little bit of the prompt. Whereas we still mostly talked about structure and introducing some structural components to a prompt, we have not really breached the more complex cases where you need potentially multi-step reasoning and so on. So this is where usually with standard prompting, we have shortcomings because with either zero shot or few shot approaches, so providing one example with a task or just few input-output examples, you might get something plausible, but it might still be incorrect. And maybe that's something that you have experienced in the past, and this is what motivates this whole session the best. So should you have any example that you can think of where you thought or you felt disappointed, frustrated with using be it ChatGPT or any other tool, that it's not going into the depth that you would have expected it, or if it's not following the thinking process that you as a, most of us are very specialized in our working. And we usually, when we go through some task, we meticulously follow some processes, we try to integrate some standards and so on. But if you felt that, that tool doesn't do what I want, maybe you can drop that example that you can think of in the chat as well. So we can, in an interactive way, pick it up later on as I show multiple methods of advanced techniques. So these in general can help with tasks in the domains that require you to dive deeper a little bit. So be it like with arithmetics or with reasoning, with strategic planning and so on, you usually require a more structured approach and just go beyond the few shot input-output examples to get structured, reliable, and verifiable outcomes. And usually this is just with more challenging tasks. And this is what we want to uncover today. There are multiple techniques that we will look into today. And I have prepared deep dives into 4 of which, whereas chain of thought here, the first one that is on this tabular overview, we will part by part populate this tabular overview. Chain of thought will be the focus. It's one of the most prominent and also effective way. And what we want to understand with each of these methods and techniques is, what's the core idea? For what problem could it be suitable? What can you actually improve? Or where are the benefits? At what cost does it come? So the computational cost, or how easy it is to implement. So we will go through each one by one. But first, chain of thoughts. Actually, funny how these icons, I should have probably switched it around. Now it's thoughts of chain, but things you realize After Effects still make us laugh, maybe. All right. Now, what is the major idea of chain of thought prompting? It is that we make the AI understand our thinking process in a step-by-step way, so that when it comes across a new problem that it doesn't know yet, it can learn from thinking examples or our reasoning, how we have uncovered some, or how we have solved a problem in the past, and then applies it to a new problem. So this extension of the input that you see in this graph is what is central to the approach. We take examples of questions and answers and demonstrate how to reason about a given task. That is very, very theoretical and not so hands-on. Therefore, let's look into an example. This example, such as most of the other examples, I am drawing them from the research papers that have originally introduced these techniques. So you would always find the link to the research papers if you're interested in looking it up at the bottom of the slide. So how is the chain of thought prompting different to the standard prompting? And it's about providing our reasoning, as I mentioned. But how do we do that? Here, the example is very easy. It's more of an arithmetical problem, and it is starts with the example of one question-answer pair, and then it's followed up by a new problem. And what do we do as an extension to the answer at the first example? And it is highlighted in blue here, we showcase to the model how it should reason as it creates an answer. So mind that everything is part of the input, what you prompt into it. And here it is a simple mathematical problem with counting how many tennis balls Roger has. Roger Federer, the reference here is funny. And then with the new question, it doesn't have to do anything with tennis balls or Roger or whatsoever. It's about a cafeteria that has apples. And what the model learns is how to answer the new question. And as it does so, compared to standard prompting, where you see with the example on the left-hand side, actually makes a mistake in calculating how many apples the cafeteria has. It comes up with the right answer with the chain of prompting technique applied. So what is basically the main benefit here? We can leverage the model's ability that is inherent with the models to recognize and replicate patterns in general. And then as it does so, it just replicates how we would reason about it, right? It actually creates a better output. Now, how much better can that be, and when is that applicable? That is drawn from the same research paper, and it's something that is quite interesting because maybe you are working not always with like the biggest and smartest models, but because of some restrictions, you have to work with a smaller model, or you want to work with a smaller model because it's more efficient, it's cost effective, or it's running on your own device. You cannot afford to run a very big model. So the smaller models are usually not as intelligent as the big ones. Question now, of course, is can we get away with a small model? We just applied chain of thought prompting, and then it miraculously got more intelligent. And the research paper sheds a little bit of light on it, that chain of thought reasoning emerges with model size, actually. What we have here are some graphs that indicate with 3 different models that represent the overall industry quite all right, a comparison across a small-sized model, mid-sized, and large. So for each of the models, we have a small, medium-sized, and big version. And we can tell, best by reading it from the GPT and Palm models, that the effect of using chain of thought prompting is strongest with the large models. So large meaning a larger size of parameters. And what's also interesting, on the other hand, is that it actually can, it's just by a small margin, but it can result into a weaker performance with the smaller models. And that is partially because the smaller models handle extended context not so well. These tests have been performed with challenging mathematical problems. So all of these benchmarks come from these mathematical problems, but we can still learn something from it. And it is that chain of thought in general is most effective with the bigger models, and that the technique itself can help with complex problems where you need multiple reasoning steps, and with simpler tasks you don't need it so much. There are different nuances to chain of thoughts, and it is, the first one is zero shot chain of thought, and it touches on the problem that creating these examples of how we reason about a problem is actually like not always available. Where do you get it from? And the few shots that you require, why don't we extract that from the model itself, is the core idea. And you would do that in a two-step process. And the first process is called reasoning extraction, where an initial prompt with the question is just fed into the large language model. It then generates the reasoning. And then you take the reasoning, you attach it to the previous prompt that you used for extracting the reasoning. And here you go. You then can carry on and basically create your first shot with an example. This really helps if you struggle to come up with the structure. Later on, I have some more hacks, I would say, how to come up with this chain of thought structure. But if you don't have anything, this is something that you can help yourself with. Now, one thing that you have seen here, and I have not really touched upon it, was a sentence that is used to trigger the reasoning. Let's think step by step. Now, this has been also actually discussed by the research paper that has introduced this technique. And the question basically was, is this trigger sentence the best, or can we think of other template sentences that could work better? Let's think step by step is something that I have actually also introduced when we talked about the basic prompt structure and components that you can add. And why is that so popular? Let's think step by step. And it is because it appears to be the template sentence that works best. So the researchers have tried a couple of templates, one in the category instructive, misleading, irrelevant, and so on, just to have a baseline. And the sentence of let's think step by step just scores the best accuracy in the tests that they have made. And it's simple. It's really agnostic to the task that you want to direct it to. And other sentences such as let's think about this logically is still good, or let's think like a detective step by step, or let's be realistic and think step by step, is that performs still all right, but you already have a little bit of a significant decrease in accuracy when you just say, let's think, or before we dive into the answer, think about it whatsoever. So it's simple. Anyone can use it. Let's think step by step. Now you know why this is so popular. Another method of chain of thought prompting is contrastive CoT, and it is the idea of learning from mistakes that we know from our own behavior. Actually, positive reinforcement is good, but negative reinforcement also helps. If I make a mistake with one thing, then I will surely understand that there was some shortcomings with it, or potentially even punishment, whatever. And here we use the larger idea of chain of thought, but we introduce a mistake. How do we do that? In the research paper, they have a very good demonstration on how you could extend chain of thought. Earlier, I have introduced to you chain of thought always comes with the example that then is used to create an answer on a new unseen problem. And here, the extension is this one here, the wrong explanation. So in the research paper, they have a simple, again, mathematical or arithmetical challenge, which is about how many pages of a letter are written, and the way how they create the wrong explanation is basically just to shuffle around the calculations that occur stepwise, and so they basically shuffle around some of the objects here. And this is a very, very simple and effective way to come up with wrong examples, or wrong explanations, as it's called here. You just see you just reapply the structure, but you change information points that allows to highlight like how you should not do it. And in fact, this, in the example of the research paper, has the result or outcome that it performs the task all right with a new task given. So the new task then, as we have seen with the other example, is a new unseen problem, but the way how it approaches it, I think I don't need to go into the example explicitly, but what the model has learned was to address the issue of the plausible errors. So because one tendency that models have is to just follow along with what's most plausible. But if you have shown it once that it could run into an error, it avoids these errors, which is like, let's say, a cheap way of training a model to act more towards the intended behavior. Now, another interesting chain of thought sub method, if you want, is a faithful chain of thoughts, and it's basically the idea to extend reasoning by deterministic processing. So you have, in general, the capability of a large language model that it can create text very well, but when it comes to calculating stuff, it can have shortcomings. And here, the idea is that we allow it to generate the text in terms of how to approach the problem, but we don't trust it with the eventual calculation or running the numbers. But we use, as we will see in the example, we use code that will then be executed and interpreted by the model. So here the task is quite simple. We have Royce that takes 40 minutes, more than double the time that Rob takes for a task. So if Rob takes 2 hours, how many minutes does Royce take? So you have to take the 2 hours of Rob times 2, which is 4 hours, 240 minutes plus 40 minutes, which is 280. So it's a multi-step calculation. And with the standard prompting, you get the wrong result. With chain of thought, it's the wrong result because it fails the calculation. And how is the faithful CoT different? Also, the least most prompting is different. I will explain least most earlier as well, later on as well. So how is the faithful CoT different? We ask the model to create the Python code. It is being executed, not by the model, but by an interpreter in the back. And then we arrive at the right result. I actually do that myself a lot in terms of data analytics. So the models are really good in creating the code that you need to run an analysis, but they cannot compile the code that data analytics involves, at least not from shelf. And then with all of the analytical outcomes, statistical values, and so on, I feed it back to the large language model to ask it to interpret the statistical values, and it does that very, very well. So in that regard, faithful always follows a structure that is twofold. It is, on the one hand, the translation part where you have the query coming in and the language model makes the reasoning about it, but then the problem solving, meaning to say the execution of the code, is done in a deterministic way. Deterministic means that it's not based on probability, but based on either or, black or white. It has no room of error in this regard. All right, and a last piece that is also interesting is auto CoT, or automatic chain of thought. And this is basically the idea to reduce the manual effort. And the graph here is really noisy. I've taken that from the original paper. What the idea is, if you have a lot of questions, why don't you cluster the questions first? And this is what is basically represented here. Cluster the questions first and pick a representative question from each cluster in order to create an answer for this. So we are still in this question answer game. And it's also here created with the let's think step by step. And once you have created this question-answer pair, you can use that to feed it back into the prompt. So this assumes that you potentially have a couple of questions and you want to iterate on it and automatically create more of these question answer pairs. So this is why it's called automatic, because there's a degree of automation in how you create the question answer pairs. And again, in red color, you see here, let's think step by step. I think it's another highlight on how central this tiny sentence is when applying chain of thought. Now I have a hack. New category or a new segment that we didn't have with the previous prompt labs. It is one of Siggi's hacks. So it is something that you can do with ChatGPT, one of the most popular tools anyways. You could do something similar with any other chat assistant that you use. And it is to create your question answer pairs for chain of thought prompting in a way that it's automatic. All right, how do you do that? Now, the first thing that you need to do is open the context menu with your account, go to settings, and then you can, under data controls, you can export the data. That would be your entire chat history. You can then, if you have that downloaded, which is an HTML file, at least the last time I have exported it, it was an HTML file, you can use this chat conversation history and put it into a prompt. This prompt is one that I have formulated, so if it doesn't work, send it back to the author, send it back to me, and share your feedback. And what is the idea here? I want to use my conversation history in order to come up with a few short chain of thoughts examples to improve the overall prompting that I can do in a given area. So let's assume you don't want to have like your entire history, but you have one longer conversation which emerged over time whatsoever. Maybe there are two separate chats and you are convinced that from the way how reasoning has been applied here and how a given problem was solved, there's something that can be learned in a way that you have the representative question, you have the rationale, and you have the answer. And yep, this is what this prompt would basically do here in this area I highlighted. You get this out from the prompt. So you basically copy paste the content from your chat history into the input up here, and you're good to go. That's it. New segment over, Siggi's hacks. And this also concludes chain of thoughts. So let's wrap up what we have learned. Its core idea is that it's sequential, step-by-step reasoning. It can help with multi-step reasoning tasks and can even help with mathematical problems or common sense problems. It can help you to have significant gains over the baseline in terms of intelligence or reasoning improvements. And computationally, it's actually relatively low in terms of cost relative to others, for sure. We will see that in a moment. And in terms of implementation, you need the shots few shots, or even if you don't have examples, zero shots, you can create them with the let's think step by step template phrase. All right, let's move on. Tree of thoughts. I find this is one of the most exciting sounding methods, so let's dive into it. What is it about? Basically, you can picture this in a way that you can imagine three experts pondering about the best approach to solve a complex problem. And each expert contributes a different idea, and there are various options that are being explored and evaluated, and only the best options would be further discussed, and there is something like an iteration, discussion goes on, and the circle arrives at the best decision. So this is also basically this imaginative example is what I come up with, but this is basically what also the research paper wants to highlight with the graph that they attach to their research paper. You have a root, which is your question, and you generate different thoughts from it, which is here the first layer. And then you evaluate each of these thoughts, and only if the thoughts are worthwhile pursuing, you go and continue with the next layer. And the next layer is then informed by a little search algorithm. By the way, this time I have a little more text on the slides because we also share the slides, and I know that people, even with the YouTube videos, like to stop, read it again, so feel invited to do so. An example for tree of thoughts prompts. I found this quite interesting because you can, even though it sounds relatively complicated, you can mimic it yourself pretty quickly. Take these two examples. One is a more elaborate prompt and one is a shorter one. The shorter one is so short I can read it out. So imagine the three different experts are answering this question. Each expert writes down one step of their thought process and then shares it with the group. After that, all experts move on to the next step. Repeat this process several times. If an expert finds that they are wrong at any point, they leave the round. The question is, how does the weather affect our mood? So the question comes at the very end, and at first the let's say the process is set up. In a similar way, a little longer the prompt, a little, let's say the structure is a little more explicit, but the idea of the prompt is basically the same. I suggest you check that out afterwards, but here basically what this prompt does is that it decomposes better the tasks that it's supposed to follow across the phases: brainstorming, evaluating, then more depth, selecting the most promising solution, and a summary at the back. So this is very, very good if you want to have a more human-like problem solving with your large language model. Maybe also for strategic planning, if you're not happy with just one option, but you want to have more options and you want the model to reflect something like a trial and error or structured thinking process. This is tree of thoughts. As I've mentioned earlier, chain of thought will require a little more time. Tree of thoughts is relatively concise. One thing that I want to highlight is that it is, in terms of computational cost, relatively high, because the more you open up the width, so let's say at each point you want to have 5 options presented and then discussed and so on, it is a lot of work. And it can also be complex because how do you actually evaluate the different options can be tricky. But we will come to something like an evaluation process in a moment. Self-consistency is the next technique that we want to check out. And here the idea is to go the next step beyond tree of thoughts and also the chain of thoughts. And the major concern is to make it more reliable and accurate, large language model outputs in general. So I think here reliability and accuracy is at the core of it. Now, how can this look like? There's a very recent research paper from 2025 that now is a lot of text again, but we can just follow through one by one in terms of what the process here is, and you will understand very easily what's the core idea here. So it starts with a question, and again, we have a mathematical problem. And there is one right answer, and it's a multiple choice question. And the answers are being generated with tuning some parameters. For instance, what's most likely to be used is the temperature, but you can also just rerun it a couple of times at the given temperature. And this just induces randomness. And as you have these different answers or paths of reasoning or thinking, what you could do next is to just count what is the answer that was suggested the most. So you can just go by the count. And this was the first idea. And the recent research paper, it's just a month old actually, it suggests to do something different. And it suggests to use confidence. So after having the answer generated, you ask the model to rate how confident it is with the proposed answer. And then instead of choosing the train of thought that is the most prominent, and in this case, it is proposed answer C, which is wrong. Here you see the count in the aggregation. You choose that train of thought that has the highest confidence. And this is basically here in green what was highlighted by the researchers. It is the confidence-informed self-consistency. So it's a means in that regard to help yourself using the large language model again to evaluate its prior outcome. This can actually be solved with code as well. So be it generating the samples, extracting the answer, and do a voting either by counting or confidence. I have an exemplary implementation of this here written in a Python code. Please, yeah, well, do your own implementation from the back of this. It just highlights how you can translate it into your own solutions quite neatly. And this is self-consistency already wrapped up. What's the core idea is that you find consensus across multiple samples. And this works best if you have discrete answers, actually. So we have just highlighted the mathematical problem, but also with question answers where it's quite explicit, okay, what's wrong and what's right. This works very well. It is boosting the accuracy and robustness, as I've shown. It still is relatively high computational effort because you need to generate the different trains of thought, but it's not so hard to implement because the sampling and the aggregation logic on how you want to vote is not as complex as with the tree of thoughts. All right, now reasoning and acting, or in short, react. This will be familiar to you if you have recently used something that felt like an agent or was coined to be, let's say, an agentic AI feature. All right. What's the core idea here? The core idea is that you extend the capabilities of a large language model by combining the verbal reasoning with the ability to take actions. And these actions usually are informed by an external environment. I have a very simple example here, and this will explain how this process usually follows 3 steps. It's 1, 2, 3. And it starts, well, let me introduce the example first. The input is basically what is the population of the capital of France. So if we would want to solve it, we would first need to figure out, okay, what's the capital of France? It's Paris. And then, okay, what is the population of Paris? So at first, the model is instructed to share its thought. So I need to find the capital of France first and then find its population. So this is the thought first. Then it's instructed to trigger an action. Here, it's a search action of the capital of France. This can be linked to multiple functionalities, let's say. It can be information retrieval, it can be some function calling or like tool with calculation, a calculator, let's say. It can be querying a database, it can be using an environment such as the desktop or web browser, or it can be using a vision, a model, or tools that involve reading images or so on. So this can be multiple, whatever the action is, but what's most important is that it derives the observation from it. So the observation is what it makes sense from the search. And here it says Paris is the capital of France, and then the process goes into a loop and repeats itself. Thought, action, observation. And then it would probably arrive at a point where it would say, okay, now the capital is Paris. I need to find the population of Paris. And it would start with a search as a next point again. So if you repeat this over and over, you find something like a structure as shared by the research paper here, where they have compared how would a model perform if it had only done the standard prompting, so without chain of thought, then with chain of thought, then act only and react. This is what they have compared, and they found that the combination of thinking first, then launching an action, observing what the action has resulted in, it may result in nothing. And this is something that you would see a lot with agentic work, agentic processes or agentic AI. that it actually tries to act on something, but then nothing comes back, and it gets caught in a loop sometimes if it is not provided with the right environment. And then it loops forward and forward until it has a finish action here in this context. This can be implemented pretty neatly also here with a popular framework, again in Python. Help yourself copy paste it. It's a LangChain implementation. I just wanted to highlight how easy it could be to introduce such techniques in your own work environment. And this wraps up React. So where is it used best? If you want to have reasoning and external actions. It enables basically new capabilities. I would want to highlight that as well, tool use. And in that regard, it drastically reduces hallucination. In terms of how the model doesn't need to do a lot of more work than calling a tool, it's actually also, in terms of the computational cost, relatively moderate. And it's also, in terms of implementation, not so hard, which is also why with agents now, it's such a big topic. Lastly, I want to share something. It's actually second last, but before I go to the very last point, I want to share an integrated framework where you can combine all of the techniques to have some synergies from it. Imagine you have a user query first, and then with just as simple as let's think step by step, you can create a chain of thought, decomposition of the reasoning tasks. As a next step, once the reasoning tasks are decomposed and the model has shared how it would go about it, you can ask it to branch out and create multiple in parallel running chains of thought. And then with self-consistency and confidence voting, you can select the one that you want to trust best with. And self-consistency probably for when you are in a domain of low confidence where you want to have that, and then use React on top of it when external tools are available. Some of you might actually be disappointed that I have not shared more techniques. And boy, there are so many. And I wanted to share a few just to highlight that this was a snapshot only, and that it's actually a very vivid discussion about how many more and better and advanced techniques there are. Let me highlight these 6 in representation of the many that there are. A graph of thoughts, similar to the tree of thoughts, but you have a graphical representation of the branches, and it's not a tree structure, but it goes beyond that. And therefore, it can reach a better structure and more depth. So let's say a leveled up tree of thoughts. Next, the step back prompting, actually quite intuitive. It's inspired by how we do our problem solving as well, where we might want to take a step back to see the bigger picture. This technique comes with a prompt that first would ask to derive like a higher level concept or principles that are relevant to the specific question before the solving starts. It's very, very simple in terms of how you want to trigger that as well. Let's just think of the bigger picture you could ask and such. chain of verification as a next technique. It's about hallucination, and it is basically the idea to have a mechanism involved to criticize, and the large language model shall self-criticize its prior prompt. So systematically, you want to verify whether what it has claimed is actually factual. I suggest to link it to tool use. So if you have, for instance, access to a knowledge base, or if you have access to web search, then this is really, really good because it has a ground truth. You have to have some truth grounding, and then with that, you can double check in this self-critique mechanism. Self-refine goes into a similar direction, and it's, let's say, an iterative prompting technique, and it asks the model to, like, say, iteratively improve on its output through some cycles of feedback and refining. And it would be similar to how we also draft something and then revise and again and so on. And least to most prompting, we had that earlier as well, as breaking down complex problems into a series of smaller sub-problems and then go each sub-problem at a time. I think this is similar to how we would break down big tasks and then just ask the model to do one by one. We covered that in the basics in the first session as well. And active prompting focuses on optimizing the selection of examples for future prompting. So it's something that resides in the context of CoT, chain of thoughts, in order to identify the best queries, best for when you have high uncertainty and you want to support the human annotation in this regard. Wow, let's take a deep breath. That was a lot. Thank you for having such a patience and that you sticked around. And I hope you have taken away a lot from it. Yeah, I'm really glad to ponder with you about whether there are potentially some other things that one could do, or some other treasure hunting methods just to get the most out of large language models.
All right. Thank you so much, Ziggy. That was a very comprehensive session today. I have shared some links for more updates. Follow us on our social media. And if you would like to provide us with feedback in a way that we can improve our sessions moving forward, and if you have any ideas on certain topics that you would like us to cover, we are very welcome to hear that from you.